Welcome back to another video in which we will solve paper 2 variant 1 for May-June 2020. So let's start with question number 1. The speeds v kilometers per hour of 80 vehicles traveling along a road were recorded. The results are shown in the table. So you have speed and then frequency. So 10 vehicles had a speed of between 30 and 40. 18 vehicles had a speed of 40 between 40 and 50 and so on. The first part is calculate an estimate of the mean speed of the vehicles. So since you have these class intervals and not exact value of speeds, you will first find the mid value of each of these class intervals. So let me extend this table towards the right here. So I will add another column for mid value. Let's call this value x. So this is the mid value of each class interval here. So this class interval is between 30 to 40. So the mid value here is 35. Here the mid value will be 45. This will be 55, 65, and then 75. And then I will find the product of this mid value with the frequency. So if this frequency is f, I need to calculate f times x. So 35 times 10 is 350. 45 times 18 is 810. 55 times 27 is 1485. 65 into 19, 1235. And then 75 into 6 is 450. So now your mean will equal sigma fx over sigma f. So sigma means summation. So I need to add all the product values here. So this will be 350 plus 810 plus 1485 plus 1235 plus 450 divided by sigma f means I need to add up all these frequencies, and we know that the total number of vehicles is 80, so the sum of all these frequencies will be 80. So if I add the numerators, 350 plus 810 plus 450. So this is 4330 divided by 80. So this divided by 80 is 54.125, your mean value. So if you want to write it up till three significant figures, this will be 54.1. So your answer here will be 54.1 kilometers per hour, which is your mean speed of the vehicles. The next part is draw the cumulative frequency diagram. So for this, I will need another column here. So for cumulative frequency, cumulative frequency. So cumulative frequency is basically the sum of all frequencies up till that point. So here this is 10, then 18 plus 10 is 28, 28 plus 27 is 55, 55 plus 19 is 74, 74 plus 6 is 80. Now to draw the cumulative frequency diagram, I will use the upper boundaries of these class intervals. So I will use from this class interval, I will use 40, from this 50. So all the upper bounds for this class intervals will be used. So here on the x-axis you have speed and y-axis your cumulative frequency value. So for speed 40, my cumulative frequency is 10. So 40 and 10 will be this point. Then you have 50 and 28. 50 and 28 will be this. So each small block here represents a value of 2. 60 and 55. 60 and 55 will be in the middle here. 70 and 74. 70 and 74 will be this. And then the last one is 80 and 80. So 80 and 80 will be this point here. So now I can join them together to form my cumulative frequency curve. So this is how your cumulative frequency diagram will look like. The next part is use your cumulative frequency diagram to find an estimate for the median. So for the median value, you first need to take 50%, 50 percentile of total frequency. So this is 50% of 80. Your total frequency or the total number of vehicles here is 80. So 50% of 80 is 40. So now you need to find the value of speed when your cumulative frequency is 40. So let me draw a line here and see where it intersects the curve. So it intersects at this point, and then I need to read the speed value at this point. So the speed value here is 55. So my median is 55 kilometers per hour. The next part is we need to find the interquartile range. So to find the interquartile range, I first need to find the 25th percentile of total frequency. So this will be 25 over 100, which is 25% of 80. So 0.25 into 80 will be 20. So this will give me the lower quartile value. I will read the speed when cumulative frequency is 20. And then similarly for upper quartile, I will take 75% of total frequency, which will be 75 over 100 into 80. So 0.75 into 80 is 60. And then this will give me the upper quartile. So let's first read the lower quartile value when cumulative frequency is 20. So when cumulative frequency is 20, again I will draw a straight line here and see where it intersects the curve. So it's at this point, and then I will read the value. So my lower quartile is 45 and then 46. And then my 75th percentile was 60, so I will read the speed value when cumulative frequency is 60. So it will be at this point here, 60. So let's draw a straight line up till this point and then down to read the speed value. So this will be 62. So now I can write these values here. So my lower quartile was 46 and my upper quartile is 62. So my interquartile range, interquartile range will be the upper quartile 62 minus the lower quartile 46. So 62 minus 46 is 16. So your interquartile range is 16 kilometers per hour. So let's move on to question number 2 here. So the first part is describe fully the single transformation that maps triangle A onto triangle B. So if you look at these two triangles, the transformation is not a translation because the orientation of the triangle has changed. Here it's pointing upwards and then here it's pointing downwards. So this is clearly not a translation. This is also not an enlargement because the size remains the same. This is also not a rotation. So if I try to rotate it like this 180 degree, what I will get is I will have the longer edge like this. So if I rotate it like this, I will have the longer edge on this side and the shorter edge on this side. So I basically rotated it 180 degrees, or in fact, not 180, 270 degrees. So if I rotate, or in fact, 180 degrees. If I rotate this 90, 90 will be up till this point. So after 90 degrees, it will look something like this, right? So this is 90 degrees, and then another 90, it will look like this, which is 180 degrees. So the longer side is on this side and the shorter is on this side. But here I have in triangle B, I have the shorter side on the left and the longer side on the right side, which is opposite of this. So that means this is a reflection. So to find the line of reflection, I will connect the object with the image. So this vertex is mapped onto this. So if I connect this and I find the midpoint, midpoint is this value. And then I take another vertex that is mapped onto this. So this vertex is mapped onto this, connect them with a straight line, find the midpoint, which is this, and then my line of reflection will be the line that passes through these two midpoints. So if I draw a line, it is this one, which is basically the x-axis. So the transformation that maps triangle A onto triangle B, it is a reflection in this x-axis, reflection in x-axis. So that is how you will solve this part. So the next part is triangle A is mapped onto triangle C by a rotation 90-degree anti-clockwise about 1, 1. Draw triangle C. So let me just erase this. So now we have a 90-degree anti-clockwise rotation, and my center of rotation is this point 1, 1. So this vertex is already on the center of rotation, so it will not move anywhere. So let's take this vertex and join this to the center of rotation, and then rotate this line 90-degree anti-clockwise. So this is 1, 2, 3, distance is 3, and then I go the same distance 3 in the other direction 90-degree after rotating 90-degree anti-clockwise. So this point will end up here. And then similarly, so I'll erase this since I've already found where the point will lie. So I can erase this line. I don't need this anymore. So now I've found the two vertices. This will stay here. This point will move at this location. And now I have to find the location of the image of this vertex. So now if I connect this to the center and then rotate 90 degrees anti-clockwise, go the same distance, I will end up here. So this distance is the same as this distance. And the angle here is 90 degree between the two lines. So basically the line joining the object and the image with the center of rotation, they make a 90-degree angle, and this point move 90 degree in this direction, which is anti-clockwise as given in the question. So now I know the location of the three vertices. So this one was here. So this is my triangle C. I can join these three vertices to form my triangle. So this is my triangle C. After triangle A is rotated 90-degree anti-clockwise with center of rotation 1, 1. Part C is triangle A is mapped onto triangle D by the single transformation P. The matrix representing P is this 2002. Describe fully the single transformation P. So if you look at this matrix, you have studied that any matrix of this form K0, 0, K, it represents an enlargement with scale factor K and center 0, 0 or the origin. So here our scale factor will be 2 because our value of K here is 2. So if you can't remember that this matrix is a matrix that represents enlargement, we can actually perform the transformation and then see what it represents. So let me show you that method as well. So you have studied that if you have a transformation matrix T, or you have P in this case, let's call this transformation matrix P, and if you apply it to the object, you get the image matrix. So let's find this P times O. So my P is 2002, which is my transformation matrix, and my object is triangle A. So I need to find the vertices of triangle A 1, 1, 4, 1, and 2, 2. So 1, 1 is this one, and then this is 4 2, and sorry, this is 2 2. So the next one is 2 2. So 1 1 2 2, and this is 4 1. So let's do this multiplication and find the image, which is the triangle D. So if I multiply this row with this column, 2 times 1 is 2 plus 0. 0 times 1 will be 0. So this will be 2. This is 2 times 2, 4. 0 times 2, 0. So this will be just 4. This will be 8. 0 times, so this row multiplied by this column. 0 times 1 is 0 plus 2 times 1 is 2. So 0 plus 2 is 2. This will be 0. This will be 4. This will be 0 plus 2. So these are the vertices of triangle D when we perform this transformation P on triangle A. So let's mark these vertices 2, 2, 4, 4, and 8, 2. So 2, 2, let me actually use a different color. So 2, 2, 4, 4, and the last one was 8, 2. So let me draw this triangle D as well. So now from this, when we applied the transformation and we have drawn this triangle D, we can clearly see that this is an enlargement which maps A onto D because the size has changed. Now, the next thing that we need to do is find the center of enlargement. So to find the center of enlargement, we join the image and the object through a straight line. So I will join this. So this vertex is mapped onto this vertex after the enlargement. So I will join these two with a straight line like this. And then this vertex is this one. So this vertex is mapped onto this one after the enlargement. So this is vertex of triangle A, which is mapped onto this vertex of this red triangle D. So now I can join these two with a straight line as well. So if I join these two with a straight line, so the intersection of these lines is at origin. So this is my center of enlargement. And then to find the scale factor, I can take this length of D, which is 1, 2, 3, 4, 5, 6 units. So scale factor will be image over object. So length of this image is 6 divided by the length, same length in the object, which is triangle A, is 1, 2, 3. So your scale factor is 2 with a positive sign because both the object and the image are on the same side of the center of enlargement. If triangle D was somewhere here on the opposite side, then you add a negative sign to your scale factor. But since both the object and the image are on the same side of the center of enlargement, your scale factor is positive. So now you have found out what transformation P is, even if you didn't know that this matrix represented an enlargement. So this is an enlargement with scale factor equals to 2 and your center is 0, 0. So this is how you will fully describe this transformation P. Question number 3 is rearrange m equals to 4n minus 3 to make n the subject. So to make n the subject, I will take this 3 to the other side. So I will get m plus 3 equals to 4n, and then bring this 4 here. So this will be m plus 3 divided by 4 equals to n. So your n value is m plus 3 divided by 4. Part B is solve these simultaneous equations. So I will use the elimination method. I can multiply this equation by 2. So this will give me 10x as well. And then I can subtract the two equations to eliminate the variable x. So I will write the first equation as it is, 10x plus 7y equals to minus 3. And then I will multiply this by 2. So this will be 10x minus 2y equals to 6. And then since I'm subtracting, I'll switch the signs of the second equation. So this will become negative 10x plus 2y minus 6. 10x minus 10x is 0. 7 plus 2 will be 9y. and this will become minus 3 minus 6 will be minus 9. So y equals to minus 1. And then I can substitute minus 1 in this equation here. Sorry, y equals to minus 1 here. So I will get 5x minus minus 1 equals to 3. 5x plus 1 equals to 3. 5x equals to 3 minus 1 is 2. X is 2 divided by 5. 0.4. So x is 0.4, y is minus 1. Part C is solve this equation, show all your working and give answer correct to 2 decimal places. So this is a quadratic equation. I will use the quadratic formula to solve this. So you will have x equals to minus b. So your a is 5, b is 3, and c is minus 1. So minus b will be minus 3 plus minus square root of b square, 3 square minus 4ac, 4 into 5 into minus 1, divided by 2a will be 2 times 5. So x equals to minus 3 plus minus, this will be 9 plus 20, which is square root of 29, divided by 10. So your x is equals to minus 3 plus square root of 29 over 10, or your x equals to minus 3 minus square root of 29 over 10. So minus 3 plus square root of 29 and then divided by 10 gives you 0.2385. So I can write it as 0.24 because you have to give your answer correct to 2 decimal places. And then this value will be minus 3 minus square root of 29 and then divided by 10. So this is minus 0.84 up till 2 decimal place. So this is 0.24 or minus 0.84. Question number 4 is Anton invests $6,000 in an account for 5 years. The account has compound interest rate of 2.5%. At the end of 5 years, he spends $4,200 of this money on a family holiday to Malaysia. Part A is how much money is left in the account. So first we need to calculate what is the amount of money in the account after 5 years before he spends the 4,200. So you have compound interest. So amount will be the principal investment into 1 plus rate over 100 to the power n, where n is the number of years. So let's substitute the values. Your principal investment is 6,000. So this is 6,000. 1 plus your rate is 2.5%. And the time is 5 years. So let's calculate this. 1 plus 2.5 over 100. And then this to the power 5 into 6,000. So the amount is $6,788.45. And then money left will be the amount after all the interest is added, which is 6,788.45 minus the amount he spent, which is 4,200. So this will be the money left in the account, 6,788.45 minus 4,200. So this is $2,588.45. That's the money left in the account. The next part is Anton changes $800 into Malaysian ringgits for his trip. The exchange rate is $1 to 3.16 ringgits. He spends 2,250 MYR and then changes the remaining money back into dollars. The exchange rate on his return is this. how many dollars does he receive on his return. So we have to go step by step and see how much money does he get at the end in dollars. So the first thing is that he changes $800 into Malaysian ringgits, and the exchange rate is so dollar ratio MYR 1 ratio 3.16, and he had $800 and he got X ringgit. So let's calculate X. Your X is, I will cross multiply like this. So X times 1 is X, 800 times 3.16. So that's the Malaysian currency. He will get 2,528 ringgit. So then he spends 2,250. So MYR left will be, out of these 2,528, he spent 2,250. So how much money is left? Wait, minus 2250. So he has 278 ringgits left, which he changes back to dollars at this exchange rate. So again, we have dollars ratio MYR 1 ratio 3.27, and then you have to find the dollars. Let's call them Y, and he changes this remaining amount 278 back to dollars. So again, I will cross multiply like this. So I have 3.27Y equals to 278. So Y will be 278 divided by this. So 278 divided by 3.27. So this is $85.02, but you have to give the answer to the nearest dollar. So to the nearest dollars, this is $85. That's the uh, amount of dollars that he will receive on his return. Part C is Anton invests $1,500 in another account. The account has a compound interest rate of P%. At the end of 3 years, there is $1,598.85 in the account. Calculate P. So this is again compound interest that we used in the one of the previous parts as well. So the compound interest formula is amount in the bank will be your principal investment into 1 plus rate over 100 to the power n, where n is the number of years for which you invest the money. So the amount at the end of 3 years is 1598.85. The principal investment at the start was 1,500. 1 plus your rate is P%, so P over 100. And the time period is 3 years, so your power will be 3 here. So you only have P as the unknown in this equation. So let's solve this. I will take this 1500 to the other side. So it is being multiplied here. So it will go in the denominator on the other side. So 1 plus P over 100 to the power 3 will be 1598.85 divided by 1500. And so let's calculate this. 0.85 divided by 1500. So 1 plus P over 100 to the power 3 is 1.0659. So I'll take this cube to the other side. So this will become cube root. So 1 plus P over 100 is cube root of 1.0659. So let's calculate this. Cube root of 1.0659. So 1 plus P over 100 is 1.0215. P over 100 will be, this one will be subtracted on the other side. I will be left with 0.0215. And for P, I will take this 100. It will be multiplied here. So I'll move this decimal 2 places to the right. So I will get P equals to 2.15, which is your rate. So that's how you will calculate the value of P, which is 2.15. So let's move on to the next question, which is question number 5. A company makes and packages chocolate bars. This box contains a chocolate bar. The box is in the shape of a triangular prism. Show that x equals to 4.5. So this is a right angle triangle. I can use the Pythagoras theorem. My hypotenuse is 7.5. So 7.5 square equals to 6 square plus x square. So x square will be 7.5 square minus 6 square. 7.5 square minus 6 square. This is 20.25, and then I'll take the square root of this to get the value of x, which is 4.5 that you had to show. The next part is these boxes are packed into cartons. Each carton is a cuboid with internal dimensions 30 by 28 by h centimeter. 80 boxes fill one carton completely. Calculate the value of h. So you have this cuboid carton which you fill up with your chocolate boxes. So the dimensions are 30 by 28 by h. So we can calculate that number of boxes that fill one carton will equal to the volume of carton divided by the volume of the chocolate box. So you're basically dividing the volume of this carton by the volume of this chocolate box to see how many of these chocolate box completely fill one carton. And we are given that 80 boxes fill one carton completely. So this number here is 80. Volume of carton will be, since it's a cuboid, so it will be length into width into height. So 30 multiplied by 28 multiplied by h divided by volume of chocolate box. So volume of chocolate box will be the area of this base or the cross section, which is a triangle, multiplied by this height of this triangular prism. So height is 14. So the base area will be 1 by 2 into base is 6 into the height is x, which is 4.5. So this is the base area of this prism, which is a triangle, and then we multiply it by the height, which is 14, to get the volume of one chocolate box. So now we have this equation, and h is the only unknown. We can calculate this. So let me first calculate the value of this denominator. 1 over 2 multiplied by 6 multiplied by 4.5 multiplied by 14. So this is 189. So 80 equals to 189, and the numerator will be 30 into 28. So 840h. So if I take this 189 to the other side, it will go in the numerator. 840 will come down. So my value of h will be 80 multiplied by 189 and then divided by 840. So 80 into 189 divided by 840. So this is 18. H equals to 18 centimeters. Part 2 is one day the company packs 37,500 of these boxes into cartons. How many complete cartons are packed that day? So you have number of boxes that are packed into the carton. So number of chocolate boxes will equal number of cartons packed, number of cartons packed multiplied by 80, because each carton holds 80 chocolate boxes. So if you multiply 80 by the number of cartons packed, you will get the total number of boxes that you have packed. So the company packs 37,500 of these boxes. So 37,500 equals to number of cartons packed. So number of cartons multiplied by 80. So this will give you number of cartons equals to 37,500 divided by 80. So 37,500 divided by 80 gives you 468.75. Now the question asks how many complete cartons are packed. So that means 468 cartons are completely packed, and then 469th carton was packed up till 75% of its capacity. So you haven't fully packed the 469th carton. So the total cartons that are completely packed is 468. Part C is the company sells the chocolate bars to shops for $0.70 each bar. The company makes 40% profit on each bar it sells. Work out the cost to the company for producing each bar. So cost price, let's call it X. Then your profit is 40%. So 40% of X is your profit, which is 0.40X. And then the company sells the chocolate bar for $0.70. So that means the cost price X plus the profit 0.40X equals to the sale price that the company sells the chocolate bar at, which is 0.70. So this is 1.40X equals to 0.70, and X will be 0.70 divided by 1.4. So this is $0.50, which is the cost price at which the company produces each bar. The next part is a shop buys 1 carton of chocolate bars. They sell 3 by 5 of the bars at a profit of 30%. They sell each of the remaining bars at $0.84. Calculate the overall percentage profit made by the shop from selling the all 80 bars. So to calculate the percentage profit, we need to find the cost price and the sale price of these chocolate bars, and then calculate the profit and percentage profit. So first let's start with the cost price. Cost price of these 80 bars. We know that the company sells them at $0.70 for each bar to the shops. So the shop buys 80 of these. So the total cost price for the shop is 80 into 0.70. So the shop buys these at $56, the total cost price for all these 80 bars. Now let's look at the sale price. So I will divide it into two parts. First, we will look at these that they sell at 30% profit. So this is 3 by 5 of the total bars. So I'm looking at 3 by 5 of the bars. So let's look at first the number of bars will equal 3 by 5 of 80. So 3 by 5 multiplied by 80. So these are 48 bars. Now sale price of 1 bar. So 30% profit means your cost price is $0.70 plus the 30% profit, which is 0.30 of 0.70, the cost price. So your 30% profit of your cost price. So this will be 0.70 plus 0.30 into 0.70. So this is $0.91, the sale price of 1 bar. And then sale price of 48 of these bars that are sold at 30% profit. 48 bars will be 0.91 into 48. So this into 48 is 43.68. So this is $43.68. And now we look at the other remaining bars that are 2.2 over 5. So 3 over 5 are these, and the remaining will be 1 minus 3 over 5, which is 2 over 5. So 2/5 of the bars, let's look at their cost price and profit, or sorry, sale price. So first we need to calculate how many bars are there. So number of bars are now 2 by 5 of 80. 2 by 5 multiplied by 80. So these are 32. And sale price of 1 bar in this category, in this 2 by 5 category, is $0.84. So now sale price of 32 bars will be 0.84 multiplied by 32. So this is $26.88. So out of the 48 bars, when you sell these 48, your total sale price is 43.68, and for the remaining 32, your total sale price is 26.88. So the overall sale price, overall total sale price for 80 bars is now equal to 43.68 plus 26.88. 43.68. So this is $70.56. So now this is your total sale price. Your total cost price was 56. So your profit is 70.56 minus 56. So this minus 56 is $14.56 is your total profit that the shop will make on these 80 bars. The question asks you to calculate the percentage profit. So percentage profit will be the profit, which is 14.56 divided by the cost price, which is $56, and then multiplied by 100. So 14.56 divided by 56 into 100. So the percentage profit on these 80 bars is 26%. So your answer here will be 26. Question number 6, part A. The table shows some values for y equals to x cube over 4 minus x plus 1. First part is complete the table. So the missing value is when x equals to 3. So let me substitute x equals to 3 here. So I will get y equals to 3 cube over 4 minus 3 plus 1. So 3 power, 3 divided by 4 minus 3 and then plus 1. So this gives you y equals to 4.75. The next part is you have to draw the graph of this equation for x equals to from x minus 3 till 3. So let's plot this table. So your first value is minus 3 and minus 2.75. So minus 3 and minus 2.567. So it will be in the middle of this small block here. So minus 2.75 will be this value here. Then you have minus 2 and 1. So minus 2 and 1 will be this value. Minus 1 and 1.75. So 1.567, 1.75. 0 and 1, 1 and 0.25. 2 and 1 will be this. 3 and 4.75. So 4.5, 6, 7, and then 4.75 will be this value. So now we can join these points through a smooth curve. So let's try that. So this is how your curve will look like. The next part is on the same grid, draw the graph of y equals to 1 over 3x plus 1. So let me take a couple of values of x. So if x is 0, then y will be, this will become 0, so this will be plus 1. And then if x is 3, 3 over 3 is 1, 1 plus 1 is 2. So you have two coordinates, 0, 1 and 3, 2. So let's plot those. 0, 1 is this point, and then 3, 2 is this one here. So this is the other one. So now I can join them through a straight line. So let's try that. So this will be your line for the equation y equals to 1 over 3x plus 1. The next part is use your graph to find all the values of x where the line y equals to 1 over 3x plus 1 crosses the curve here. So these will be the intersection points here. So I can see that this would be my first point here. The second point is 0, 1, because we know that we have this point on the equation of the curve as well as on the equation of the line as well. So this would be my second point, and third point where the line and the curve intersect is this point here. So this will be minus 2, 2.1, 2.2, almost minus 2.3. Here the x value is 0, and here the x value is 2.2. You can say 2.25. It's in the middle of this small block. So the three values of x will be minus 2.3, then 0, and then the third value is 2.25. So these are the values of x where the line crosses the curve. The next part is the values of x where the line crosses the curve are the solutions of the equation ax cubed equals to bx. Given that a and b are integers, find a and b. So that means if we try to solve these two equations simultaneously and eliminate the variable y, I will get this solution equation, which is ax cubed equals to bx. So I have y equals to 1 over 3x plus 1 and y equals to this. So I can use the substitution method to solve these equations simultaneously. I will substitute this value of y here. So if I substitute this, I will get x cubed over 4 minus x plus 1. I replace this y here and then equals to 1 over 3x plus 1. So now I need to convert this equation into this form. So I have x cube on one side and bx, so coefficient of x on the other side. So I'll take everything towards the right side except this cube value here. So x cube over 4 equals to 1 by 3x plus x, and this will become minus, so plus 1 and then minus 1. So this will be 0. I will get x cube over 4 equals to 1 by 3x plus x. Now if I take the LCM on the right side, I will get x cube over 4 equals to x plus 3x over 3. And let me continue here. So x cube over 4 equals to 4x over 3. Now you have this form where you have x cube on one side and x on the other side. But remember, the question says a and b are integers. So I cannot simply say here that a is 1 by 4 and b is 4 by 3. I need to convert these fractional values into integers. So I can simply cross multiply here. I can take this 4 to the other side and bring this 3 here. So that means I will get 3x cubed equals to 16x. Now these are integer values, and now I can make a direct comparison with this equation here. So my a value is 3 and my b value is 16. Part B is here are four equations. The graphs of three of these equations are sketched below. Write the correct equation below each graph. So we can start with the first equation here. So if I equate it to 0, I get x squared minus 2x equals to 0. If I take x common, so basically I'm trying to solve this quadratic equation and find the uh, roots or the values of x. So I get x into x minus 2 equals to 0. So x equals to 0 or x equals to 2. So that means the curve for this equation will intersect the x-axis at x equals to 0 and x equals to 2. So this looks like a sketch where the curve is intersecting the x-axis at x equals to 0 and x equals to 2. And you can double check as well. If you substitute x equals to 0 here, your y value will become 0 as well. So 0 minus 0 will be 0. So y value is 0. So that means it's passing through the origin. And then the other x-axis intercept is at x equals to 2. So that means for this equation, the curve is this one. So I can write x squared minus 2x here. Y equals to x squared minus 2x. The next one is, so let me bring it here. 2x squared minus 2 equals to 0. So this means 2x squared equals to plus 2. X squared equals to 1. So x will be square root of 1, which can be plus or minus 1. So for this equation, my x-intercept is plus 1 and minus 1. So this looks like a curve where it is intercepting the x-axis at minus 1 and then at plus 1. And when x is 0, if I substitute x equals to 0 here, my y value is minus 2. So when x is 0, y value looks like minus 2. So this equation looks like it's satisfying this curve. So we can write this here. So y equals to 2x squared minus 2. Then let's solve this one next. So x squared plus 2x equals to 0. So x into x plus 2 equals to 0. So x equals to 0. So this is 0. And or x equals to minus 2. So the curve for this equation will intersect the x-axis at x equals to 0 and minus 2. So there's no curve that is intersecting the x-axis at 0 and minus 2. So this one this doesn't satisfy any of the curves, so we can move on. So let's look at this one next. So 2x squared equals to 0. X squared will be equal to 0 and x will be under root 0, which is 0. So that means for this equation, the curve intersects the x-axis at only one place, which is x equals to 0. And when x equals to 0, if I substitute x equals to 0, my y value is 0 as well. So that means the only place where the curve for this equation intersects the x-axis is at the origin. So this looks like the correct curve. It's passing through the origin, and this is the only point where it intersects the x-axis. So it passes through the origin x0, y0 as well, and then it intersects the x-axis here. So I can write this as y equals to 2x squared. So you had four equations and only three curves. So this was the equation uh, which did not have any of these curves. So these three are represented below. So question number 7 is the diagram shows a quadrilateral and part of a regular octagon. AB is a straight line. Form an equation in X and solve it to find X. So since this is a regular octagon, each of these angles will be 135. And this one will be 135 as well. So if this one is 135, this angle will be, let's call it Y. So Y will be equals to 180 minus 135 because we are given AB is a straight line. So this angle is 135. So remaining will be 180 minus 135, which is 45 degrees. So this angle here is 45 degrees. And now I know all four angles of this quadrilateral. So their sum should be equal to 360. So let's start with this one, 3x plus 103 plus x plus 20 plus 45 should equal 360 degrees. So 3x plus x will be 4x. And if I add the others, 103 plus 20 plus 45, it's 168 equals to 360. So 360 minus 168 is 192. 4x equals to 192, and x will be 192 divided by 4, which is 48. So your value of x here is 48. Part B is PQRST are points on the circumference of a circle O. This angle is given 32 degree. This line PS is parallel to this line QR, and these two lengths are equal. RS and QR are equal in length. Find PQT, give a reason for each step of your working. So PQT is this angle here that we need to calculate. So now if I look at this triangle PQT, this is the diameter of this circle, and this diameter makes this angle TPQ on the circumference. So this full angle is 90 degree. So I can write this as angle T PQ equals to 90 degree because it is an angle in semicircle. And then if I look at this angle PSQ, it is 32 degree. It is subtended by this arc. So this arc makes this angle on the circumference, and this arc also makes this same or makes this angle on the circumference as well. So this angle and this angle will be equal because these are angles in the same segment. They are subtended by the same arc PQ. So this angle here will be 32 degree. So I can write angle PTQ equals to angle PSQ, which is equals to 32 degrees because they are angles in the same segment. So now this is the only unknown angle in this triangle PQT. So now I can write angle PQT plus 32 degree plus 90 degree equals to 180 degree, because this is the sum of interior angles of triangle. And now we can solve this equation. So 92 plus 32 will be 124. So PQT will be equals to 180 minus 124, which is 180 minus 124, which is, oh sorry, not 190 plus 32 is 122. So this is 122. So 180 minus 122 will be 58 degrees. So angle PQT is 58 degrees. The next part is find angle QRS. So QRS is this angle here that we need to calculate. So we are given that angle, these lines PS and QR are parallel. So this angle here and this angle here will be equal because SQ is passing through these two parallel lines. So 32, this angle PSQ and angle SQR are alternate angles for these two parallel lines. So this will be equals to 32 degree as well. So this angle and this angle, they are alternate angles for these two parallel lines. So they will be equal. And then since QR and RS are equal in length, this is an isosceles triangle. So if this is 32, then this is 32 degree as well. So now I can use the sum of interior angles of the triangle again. So I will have QRS plus 32 plus 32 equals to 180. So this will give me QRS equals to 180 minus 32 minus 32, which is 116 degree. So this angle here is 116. The next angle that we need to find is TQS. So TQS is this angle in the middle here. So now if I look at this quadrilateral PQRS, so PQR and then S. So this is a cyclic quadrilateral because all four vertices of this quadrilateral are on the circumference of the circle. So using the property that the opposite angles of the quadrilateral, they sum up to 180 degree. So we calculated this angle PQT in the first part and it was 58 degrees. So this angle here is 58 degree. So now if I consider this full angle and this full angle, these are opposite angles in a cyclic quadrilateral. This angle is 32 plus 32, this full green angle, and this full green angle is 58 plus TQS, this middle one, plus 32. So only the unknown is TQS, and we can easily calculate this. So let me write down the equation here. So 32 plus 32, this full angle, plus 58 plus this angle TQS plus this angle 32 should equal 180 degree. So we can use this equation to find the angle TQS here. So let's solve this. This will be 32 plus 32 plus 58 plus 32, 154. So TQS plus 154 equals to 180. So TQS will be 180 minus 154. So this is 26 degrees. So your value of TQS is 26 degree. So question number 8 is a display notice is made by removing a sector of a circle from a larger sector. Both sectors have an angle of 110 degrees. The radii of the sectors are 80 centimeter and 45 centimeter. Part 1 is calculate the arc length L. So you have this large sector which makes an angle of 110 degree, and this is your L is your arc length for this sector, and the sign is made by removing this smaller inner sector. So if I draw this, so this is the sector that is removed from this larger sector to get this shaded area that you have. So to calculate the arc length, I'll just consider this larger sector. The radius of the large sector is 80 centimeters. So arc length L will be equal to 110 divided by 360 into 2 pi r, where r is the radius 80 centimeter here. So 80. So 110 divided by 360 into 2 into pi into r 80. So this is 153.589 centimeters, and if you want to write it up till three significant figures, this will be 154 centimeters. The next part is calculate the area of this display notice. So basically you have to find the this shaded area here, which we can calculate easily by calculating the area of this large sector, which is marked in blue, and then if you subtract the area of this small sector, which is marked in red, you will get the area of this shaded region. So area of display notice will equal area of large sector minus area of small sector. So area of large sector will be 110 over 360 into pi r square, where r is 80. And then area of small sector, the angle remains the same, just the radius changes. So area of small sector will be 110 over 360 into pi into r square, where now your radius is 45. So now I can take 110 over 360 into pi as common to make the calculation easier. And then I have 80 square minus 45 square. So let's calculate this. 80 square minus 45 square, and then multiplied by pi into 110 and divided by 360. So your area is 4199.69, and then up till three significant figures this will be rounded up to 4200 centimeters square. Part B is the diagram shows a display notice mathematically similar to one in part A. The radius of the large sector here is now 32 centimeter. Calculate the area of this display notice. So we have to calculate the area of this shaded region here. So let me call this display notice in part B as uh, display notice B, and we can call this one as display notice A. So since these two are similar, we are given that they're mathematically similar to each other. So we can use the property that the ratio of their areas will be equal to the ratio of their radii squared. So it will be area of display notice B over area of display notice A, which is in part A, should equal radius of B divided by radius of A, and then we take the square because we are taking the ratio of the areas. So now we can substitute the values here. So area of B over area of A was 4200. So 4200 equals to radius of B is this, which is 32, and the radius of A, the larger sector here, was 80. So we can calculate this now. 32 divided by 80, and then we take the square of this, and then this 4200 will be multiplied, so this multiplied by 4200. So your area of display notice B is 672 centimeters square. Question number 9 is a bag contains 10 tiles. There are 4 red tiles, X white tiles, and the rest are blue. The 2 tiles are taken at random without replacement from the bag. Complete the tree diagram. So you pick the first one without replacement, and then you pick a second one from out of the bag. So you have 4 red tiles. So 1, 2, 3, and 4 red. Then you have X white tiles. So we don't know the exact numbers, but we can say somewhat like X. And then how many blue will we have? So the total sum is 10. So 4 red, 4 plus X white, X, and then you have remaining blue. So let's call them B, should equal 10. So B will be 10 minus 4 will be 6, and this will be 6 minus X. That's exactly what you have here as well. So we can mark how many blues do we have? We have 6 minus X blue. So we had 4 red here. So now we have to complete this tree diagram. So the missing ones are these two values here. So here you are picking the first one is blue. So the probability that you get the first one blue is 6 minus x, because you have 6 minus x blue tiles, and then divide by 10 total tiles. And then when you're picking the second one, you have 9 tiles remaining. And how many red ones do you have? You have total 4 red. And since you picked the first one was blue, you still have 4 red tiles in the bag. And then what's the probability that you pick the second one, the white, given that you picked the first one was blue? So again, will have 9 remaining. And how many total white tiles do you have? You have X. Since the first one you picked was blue, you still have X white tiles left in the bag. So the probability that the second white tile you pick is white is X over 9. So the next part is calculate the probability that both the tiles are red. So the probability that you get red the first time and red the second time as well. So if you look at the tree diagram, that means we pick the first one red and then we pick the second one red as well. So it will be 4 by 10 multiplied by 3 by 9. So 4 by 10 multiplied by 3 over 9, which is 12 over 90. The next part is show that the probability that the tiles are both the same color is this. So probability that tiles both are same color, probability both tiles are same color. That's what you need to calculate. So that means you need to find the probability that the first one is red and the second one is red. So red and red, or probability that you get white the first time and white the second time as well. So you get white and white, or the third case is probability that you get blue the first time and blue the second time as well. So probability of blue and blue. So or means you will add those. So I will abbreviate this R and R. So probability of red and red as R and R. Or means plus probability of white and white plus probability of blue and blue. So what is the probability of red and red? That you calculated in the previous part, that both tiles are red, is 12 over 90. So this one is 12 over 90 plus what is the probability that you get white and white? So white, and then you get white in the second try as well. So that is x over 10 multiplied by x minus 1 over 9. So this will be x over 10 multiplied by x minus 1 over 9 plus what is the probability that you get blue and blue? So blue and then blue here as well. So 6 minus x over 10 multiplied by 5 minus x over 9. 6 minus x over 10 multiplied by 5 minus x over 9. So let's do these multiplications. So this will be 12 over 90 plus this will be x square minus x over 90 plus, so this will be 6 times 5 is 30. 6 times minus x is minus 6x. Minus x times 5 will be minus 5x. And then this will be plus x square over 90. So all these denominators are 90, so I don't need to take any LCM. 90, 12 plus x square minus x plus 30. Minus 6 and minus 5 will be minus 11x. And then this plus x square. So this will be x square plus x square will be 2x square. And then minus 11x minus x will be minus 12x. And 30 plus 12 will be 42 over 90. So I can divide by 2 both in the numerator and the denominator. So this will be x square minus 6x plus 21. And 90 divided by 2 will be 45. So this here is the same expression that is given in the question that we need to show, x square minus 6x plus 21 over 45. The next part is the probability the tiles are both the same color is 16 over 45. Show that x square minus 6x plus 5 equals to 0. So we have calculated the probability that both tiles of are the same color is this in terms of x over 45, and we're given now that this probability is 16 over 45. So 45 cancels out. If I bring this 16 here, so this will be x squared minus 6x plus 21 minus 16 equals to 0. So x squared minus 6x, 21 minus 16 will be plus 5 equals to 0. So this is what you had to show that was given in the question here. X squared minus 6x plus 5 equals to 0. The next part is solve this quadratic equation. So if I multiply 5 with the coefficient of x squared, I get 5 plus 5. So that means I'm looking for two factors of 5 that if I multiply, I should get 5, and if I add them, I should get minus 6x. So minus 5 and then minus 1. They multiply to give me plus 5 and they add together to give me minus 6x. So I'm using factorization to solve this quadratic equation. So x squared minus 5x minus x plus 5 equals to 0. I can take x common here. I can take, so there's nothing common, so I'll just take 1 common. X, so this will be now negative sign because I took negative 1 common, so x minus 5. So when I open the bracket, this minus and minus will give me plus 5 back. So I can take x minus 5 common into x minus 1 equals to 0. So this gives me x equals to 5 or x equals to 1. So x equals to 5 or x equals to 1. Part 4 is there are more red tiles than white tiles in the bag. Find the probability that the first tile taken from the bag is blue. So basically you want to find the probability of getting a blue tile out of the bag when you pick the first one. So now you're given that there are more red tiles than white tiles. So if we go back, if there are more red tiles than white, so these are white here. So that means the value of x should be less than 4. That is the only way we can ensure that the number of white tiles are less than the red tiles. That's given in the last part here. There are more red tiles. So red tiles are 4 and white tiles are x. So if red are more, then x should be less than 4. So the value of x that we will take is 1. We cannot take 5 because if x is 5, then there are more white tiles than red tiles. But the question tells you that there are more red than white tiles. So if x is 1, so that means the number of blue tiles in the bag are 6 minus 1. So number of blue tiles will be 6 minus x, which is 6 minus 1, which is 5. So you have 4 red, 1 white, and 5 blue. And 5 plus 1 plus 4 is total of 10. So now when you're picking the first tile, what is the probability that it will be blue? So when you're picking the first tile, your total tiles in the bag are 10. And how many of those 10 are blue? 5 are blue. So probability of getting the blue the first time is 5 over 10. Or you can simplify it to 1 over 2 as well. So 5 over 10, or you can write 1 over 2 as well. Question number 10 is ABCD is a field. You're given these lengths 750, 800, and 600. This angle is 90 degree. Show that angle ACB is 62.9 degree, correct to 1 decimal place. So angle ACB is this angle here. So now if I look at this triangle ABC, I know all three sides of this triangle and I need to calculate the value of this angle. So I can use the cosine rule here. So since the side opposite to this angle is this AB, so I will have AB square equals to AC square plus BC square minus 2 times AB into sorry, not AB, AC times BC into cos of angle ACB, which is this angle. So now let's substitute the values here. So I will have 750 square equals to 800 square plus 600 square minus 2 into 800 into 600 into cos of angle ACB. So I will take these two to the other side. They will be subtracted. So 750 square minus 800 square minus 600 square. So this is minus 437,500 equals to minus 2 into 800 into 600 minus 960,000 cos of ACB. So this minus and this minus will cancel out. Cos of angle ACB will be equals to this 960,000 will divide on the other side. So 437,500 divided by 960,000. Oops. So this is 0.4557 and angle ACB will be cos inverse of this. So this is 62.888 and up till one decimal place this will be 62.9 degrees. So that's what you had to show. The next part is area of the field is 375,000 meters square. Calculate the length AD. So AD is this length and we are given that the total area of the field is 375,000. So total area is the area of this triangle plus the area of this triangle. So area of triangle ACD plus area of triangle ABC. So let me write it down here. Area of field equals to area of triangle ACD plus area of triangle ABC. So area of field is 375,000. What is the area of triangle ACD? ACD is this right angle triangle. AD is unknown, so this is the height of this right angle triangle. It's 800 and the base is AD. So using the formula for the area of triangle, 1 by 2 into base, which is AD, into height, which is 800, and then plus area of triangle ABC. Area of triangle ABC. So we know that this angle here is now 62.9 degree, and I know the two sides. I know the length of the two sides that make up this angle. So I can use the formula 1 by 2 into 800 into 600, which are these two lengths, into sine of the angle between them. So into sine of 62.9 degree. So now we have AD as the only unknown here. So this will be 375,000. So 800 divided by 2 is 400 AD. So let's calculate this now. 1 over 2 into 800 into 600 into sine of 62.9. So this is 213,651.0731. And then if I take this to the other side, it will be subtracted. So 375,000 minus 213,651 0.0731. So this will be AD. So AD, in fact 400 AD will be equals to 161,348.9269. So AD will be this divided by 400. So this divided by 400, which is 403.37. And if you want to write it up till three significant figures, this will be 403 meters. The next part is calculate the angle AC D. So ACD is this angle here, and this is a right angle triangle. This side is 800. We calculated AD as 403. So if I look at this angle, I can use this is the perpendicular height and this is the base with respect to this angle. So I can use tan of ACD. So it will be tan of angle ACD equals to perpendicular over base. So your perpendicular is now AD over AC. AD over AC, which is 403 over AC is 800. So ACD will be tan inverse of this. So 403 divided by 800, and then you take the tan inverse. So this is 26.7 degrees up till 1 decimal place. So this angle here is now 26.7. The next part is X is a point on DC. So X is a point on this line DC here. AX is 500 meters. Calculate the obtuse angle AXC. So obtuse angle which is greater than 90 and less than 180 is this angle AXC here. And we calculated this angle in the previous part, angle ACD, which is 26.7 degrees. So now if I look at this triangle AXC, I know this angle, I know the length opposite this angle. This is the angle that I need to calculate, but I know the length opposite this angle is 800. So I can use the sine rule here. So sine of angle AXC over AC will equal sine of angle ACX over the length AX. So now we can substitute the values here. AXC is unknown over AC is 800. Sine of ACX will be sine of 26.7 over AX is 500. So sine of AXC will be this divided by this and then multiplied by 800 as I take this 800 to the other side. Sine of 26.7 divided by 500 and then into 800. So this is 0.7189. So AXC here will be sine inverse of this, which is 45.96 degrees. So since we are interested in finding the obtuse angle, and we know that the sine value is positive in the first quadrant and the second quadrant. So if I take sine of 45.96, so 45.96 will be somewhere here. I will get sine of 45.96 will give me 0.7189. But if I do 180 minus 45.96, I get AXC, obtuse AXC equals to 180 minus 45.96, which is 134.04 degrees. So in the second quadrant, an angle that is 134.04, I will get the same sine value since sine is positive in the first and second quadrant. So if you take sine of 45.96 or if you take the sine of 134.04, you will get the same values. And since we are interested in the obtuse angle, we found the acute angle, so we do 180 minus this 45.96. So basically on a straight line, you have 45.96 on this side and 134.04 on this side. So that's how we calculated this obtuse angle, which is in the second quadrant. And since sine values are positive in the first and second quadrant, you will get 0.7189 if you take the sine of either of these two angles. So that's how you'll solve this problem. So your final answer for the obtuse angle AXC will be 134.0 degrees up till 1 decimal place. So this was the last question. This is the end of paper 2 variant 1 for May June 2020.